When you need a quiet space to focus in your own good pace, grab your books, come take a look. You'll find your groove at the study nook.
Fractions represent numbers between whole numbers, showing how something is divided into equal parts. There are 2 bits to every fraction. Here I have the fraction 3/4. First, we have the numerator, the top number. This tells us how many parts we are talking about, in this case 3. Then we have the denominator, the bottom number. This tells us how many equal parts there are in total, 4. So there are 3 out of 4 parts, 3/4. There are some special cases for saying fractions. Here I have 1/2, 1/3, and 1/4. For other fractions, you add the sound. Here I have 1/5, 1/6, and 1/8. Let's have a look at a fraction question. Here it says Joe has to eat 8 tins of beans. He eats 5. What fraction does he have left? So, the fraction he has eaten is 5. He's eaten 5 out of 8, 5/8. There's 3 cans left. He has 3 out of 8 left, 3/8. Counting in fractions might sound difficult, but you can count up and down in fractions like you do with whole numbers. Let's try counting in tenths. We will start at 1/10 and add 1 to the numerator each time. As you can see, the numerator changed but the denominator doesn't. 10 tenths would be the same as 1 whole. Equivalent fractions are fractions that represent the same amount. They look different, but they are equal in value. For example, 1/2 is equivalent to 5/10. The diagram shows 2 circles that represent the same amount. They are just divided into different parts. Equivalent fractions show the same number. They look different, but they are equal in value. Here I have 2 equivalent fractions, 2/5 and 4/10. To get from 2/5 to 4/10, I multiply both the numerator and the denominator by 2. 2 multiplied by 2 is 4. 5 multiplied by 2 is 10. 4/10. Let's have a look at another example. Here I have 18/30, which is equal to 3/5. If I divide both the numerator and the denominator by 6, 18 divided by 6 is 3, 30 divided by 6 is 5. An important rule to remember: multiply or divide both the numerator and the denominator by the same number to get an equivalent fraction. Bar models are really helpful to help you understand how big a fraction is. Let's look at equivalent fractions that have come up in test papers. Here I have 3/10, which is equal to something 20ths. So, I have 10. I need to figure out how I can get from 10 to 20. I multiply it by 2. Whatever I do to the bottom, I have to do to the top. So 3 times 2. For the second part of this question, I'm missing the denominator. I'm going to start by looking at my numerators. How do I get from 12 to 4? I divide it by 3. Whatever I do to the bottom, I have to do to the top, or whatever I do to the top, I have to do to the bottom. So, 15 divided by 3. Mixed numbers combine a whole number to a fraction. For example, 1 3/4. Improper fractions has a numerator which is bigger than the denominator. For example, 9/5. Converting an improper fraction to a mixed number. Here I have the fraction 8/5. I know that 5/5 is the same as 1 whole. This will be my whole number. I now need to figure out what fraction I have left over. So from 5 to 8 there is a remainder of 3. So that becomes my numerator and the denominator stays the same. Let's look at another example. Here I have 38 over 9, 38 ninths. For this I'm going to do my 9 times table till I get a number that's close to 38. I'm going to stop at 5 times 9 because that's too much, so I go back to 4 times 9, which is 36. So I know there are 4 wholes with 2 left over. The remainder 2 becomes my numerator and the denominator stays the same. When converting a mixed number to an improper fraction, you need to multiply the whole number by the denominator. 3 times 7. 3 times 7 is 21. I then need to look at my numerator. The numerator is what I add to the answer. So 21 add 2 equals 23. This is my new numerator and the denominator will stay the same. Let's have a look at a test question that talks about improper fractions and mixed numbers. It says, circle the improper fraction that is equivalent to 2 and 3/8. So, I'm looking at improper fractions. I can already see one of the fractions below is not an improper fraction. Improper fractions have the numerator that is bigger than the denominator, so 5/8 I can already get rid of. All the fractions have the denominator 8, so I'm going to start off by writing my 8 times table. As the biggest numerator is 26, I'm going to get as close as I can to 26. Four times 8 is 32. I'm going to stop here because I only wanted to get up to 26. 3 times 8 is 24, so I know that there are 3 wholes with a remainder of 2. So 3 will be my whole number, 2 will be my numerator, and then I can add the denominator as 8. The next fraction is 23 over 8. Looking at my 8 times tables, I can see that 3 times 8 is now too much. I have to go back again. 2 times 8 is 16, so I know there are 2 wholes with a remainder. My remainder is 7. This becomes my numerator and my denominator stays as 8. The next fraction I'm going to look at is 19 over 8. Again, I'm going to look at my 8 times tables. I can go up to 2 times 8, which is 16. So there are 2 wholes with a remainder of 3. So this will be my numerator and denominator stays the same. I have found the equivalent fraction that the question is asking for. I am just going to check the final fraction, 14 over 8, following the same process. Here I know there is 1 whole. 1 times 8 is 8. There's a remainder of 6 to get to 14 and the denominator stays the same. I hope this helped a bit more with understanding fractions. Next time we will look at adding and subtracting as well as multiplying and dividing fractions. Thank you for watching.
When you need a quiet space to focus in your own good pace, grab your books, come take a look. You'll find your groove at the study nook.